tutorial on Proteus and AVRstudio simulation. This is the AVRstudio environment, and this is the program that we want to simulate in Proteus ISIS program. And as you can see, it's a very simple program, and it's just to blink an LED once every second. And we have compiled successfully, and therefore we'll go to our Proteus package. So we go to Proteus. Here it is. So to start our circuit building, we will come to the component mode. We click there and we go to the pick from libraries. And the first thing that we want to pick is the ATmega32. We double click on that, say OK. The next thing we have to pick is our LED, and we can go to the optoelectronics, and we have several LEDs here, but we can pick one of these that is animated color LED. We can pick one of them, double click on that and say OK. The next thing we have to pick is the crystal. Here we have the quartz crystal. We can pick this, and so we commence our circuit building by clicking on a component here and placing it here. We can rotate our crystal, and we can zoom in and out to make our diagram more clear. From our program, we can see that our LED is connected to port B, pin 0. So we come to our Proteus and we connect our LED to port B, pin 0. Our crystal is connected to pin 12 and 13. The next we have to connect our power and ground, and we can pick from the terminals mode we have power and ground. But if you look at our ATmega32 package here, we do not have pin 10 and 11 and also 31. Those are VCC and ground pins. The reason is that in Proteus we do have what they call the hidden pins. If we click on this, left click on that and come to the properties, we can see we do have some hidden pins, and which we have pin, the ground and the VCC. So by default, any pin that is recognized as ground and VCC, they have taken care of that. So we do not have to connect it in our, in our circuit building, because either way it's not here. So they have already connected it in the background. The only thing we have to connect now is our VCC to power. So we connect our power here, place it here. We have to connect our circuit to an external power supply, and as such we will need a connector from pick components, and we can type our connector. It has 2 pins, so we can use the H2, and we can use this. say okay, and we can place it here. So this is our connector to the external power supply, and on one side we can feed our our power. So we come to the terminals mode, power, we use it there. We can use this pin for power and the other one for ground. Our ground is here, so we just pick here and place it here, and we can feed we can connect the other pin to the ground. And looking at our circuit, we also have to connect the ground here. Looking at our circuit, it's complete. This one is the VCC. We have our ground here, we have our crystal here, we have our external power supply here. So we have to load our code into this into our microcontroller in the simulation package, and we have to come and see where our path is, where our X file is. And if you look at our AVRstudio, you can see your path here. Mine, it's users, Cosmos, documents, LED flash, and this is our .c. But we are going to load our X file in the simulation environment. So we come here and we double click on ATmega32 to get to our properties, and we have our program file. So we go to our browser icon and we search for our where our program is located. Mine is in C, and it's in my documents. And here we have LED flash default folder, and this is the program that we want to load in our microcontroller in the simulation environment. It's our X file. So we double click on that, and there we have it. It's loaded. So we say okay, and now our microcontroller is loaded with the program. So we can simulate and see whether our LED will blink as per the program. Here you can see the LED is on, but 1 minute is over. No, 1 second, 10 seconds are over, close to 15 seconds are over, and still it's on. Wow, but we can now see it has turned off. Well, the program, we can see the delay is 1,000 milliseconds. That's 1 second, but in our simulation, it's taking more than 1 second to turn to the other state on and off. But we shall appreciate that there's a simulation, and the bigger picture is to see whether our program is working as it should, whether the pin is blinking, and by and large that has been achieved, though the duration of 1 second is not perfect. But there are so many other factors that can influence that, including the processor in the CPU, in the PC, in the laptop, and considering that in our simulation we're using a crystal. That let's see the can stop this first and see the properties of our crystal. And yeah, it was 1 megahertz. Probably it should be 16 megahertz. Say okay, and we can start our. There we have it. It's on. Yeah, so our simulation by and large is successful. Thank you.